right, so we're going to look at functions, or characteristics of functions to start. So first off, what is a function? It's when we have a unique or consistent corresponding y value for every x value. So we can test this by doing the vertical line test. So if I have something like a quadratic, at every x value, there is a consistent, I can expect a consistent y value at each x value on the graph. Okay, what about for not a function? It's when we have more than one y value corresponding to an x value. So something like a circle. So at this point, x1, you can see that I have 2 points that can come out of the equation. So we don't have consistency there. So we can't expect the same output every time at x1. So this is not a function. Next, we talked about this in class, hopefully, that an independent variable is the x variable. It's usually represented by time. And the dependent variable is the y variable. It's usually what we're measuring. So what we're measuring. In basic student budget, we were measuring the monies that the people had at the each day. So we graph the money as the y variable. Okay. Another characteristic that's very important to situations is the domain. So it's all the possible x values. It's the values that make sense. Again, in basic student budget, what values did we use? Well, from 0 to 30 days. Okay, the range is all the possible y values. In basic student budget, I'm going to have to guess here, but the range was about from $0 to $225, I want to say. Okay, so it's, again, the possible outputs for what we're measuring. I'm going to skip down and we're going to do a little bit extra notes on domain and range. Okay, so domain and range. There are 2 different ways to write a domain and write a range. So one is set builder. I think this is the one you've seen more often. So for the domain, we're going to put the minimum x value. So in basic student budget, that would be like 0. And that's less than or equal to our x and less than or equal to our max value, which was 30 days. Okay, so the x values are sandwiched between our 0 and our 30. We can also say x is x is less than or equal to 30 if we, actually, let's not say that. Just kidding. Let's cut that. Okay, range. Okay, the range, again, is set up in the same way. The min is less than or equal to our y value, which is less than or equal to our max value. Okay, so the y value is the value we're using, basically. So what y values can I use? In basic student budget, I'm going to say that it was between $0 later. Okay, is less than or equal to y, and that's less than or equal to, I think our max was $225. So these are this is written in set builder notation. Next up, we're going to hit interval notation. This is my personal fave. Okay, so it's set up. We use all the same information as set builder. It's just set up different. So we're going to write the minimum value, comma, the maximum value. And we need to account for our greater than or equal to, or our less than or equal to, or if it's just a less than. So if you're using the signs just less than or just greater than, then you're going to use parentheses, okay? If you're using less than or equal to or greater than or equal to, we use square brackets, okay? So basic student budget. On the minimum value was 0. The maximum value is 30. So we're going to do 0, 30. And then I have to decide, do I use brackets or parentheses? So I can equal 0. So on the side that's closest to 0, I'm going to use a bracket. Could we equal 30? Let's see, we could equal 30. So on the 30 side, we're going to use a bracket. Okay, the next one. For our range, 0 is our min, comma, 225. Can we equal 0? Yes. Bracket. Can you equal 225? Yes. Bracket. Okay? Any questions? You can't answer that. Here we go. Next one. We're going to do set builder and interval notation for this graph. So go ahead and do that real quick, and then let's check in. So the domain. The domain is in set builder. See, it looks like I start at -3. So -3, something to x, and then I'm going to +3. So on the right-hand side, I added in a solid dot, so we use our less than or equal to. On the left side, it's just an open dot, so we just use our open, just our less than, okay? In interval notation, we start with -3, 3. Can I equal -3? No, we use a parenthesis. Can you equal 3? Yes, we use a bracket, okay? So this bracket corresponds with that sign, and this bracket corresponds with that sign, okay? The range. All right, so our lowest value is at 0, and our highest value is at 4. So I go 0 is less than or equal to y, and that's less than or equal to 4. In interval notation, 0, 4, they're both equal. We can get to 0 and we can get to 4, so we use brackets. That is domain and range in set builder and interval notation. Okay, what about in functions now when I have kind of funky looking functions here? Okay, so first we're going to start with f of x. What do you notice about f of x? I notice that there is a fraction. And so what can't you divide by? You can't divide by 0. You can't divide by 0. So what value of x would make the bottom equal to 0? How could we figure that out? Well, you could do it in your head, or you can be like, I'm going to set the bottom equal to 0. X minus 8 is equal to 0. So then x is equal to 8. So when x equals 8, our function breaks. Is there any other time our function breaks? No. So the domain for f of x is that x cannot equal 0. Sorry, cannot equal 8. Okay, so when I plug in 8, I get 0 in the denominator. All right, g of x. All right, same thing. We got a fraction. So let's set the bottom equal to 0. X squared plus 4 equals 0. Okay, x squared is equal to -4. And I'm like, all right, life. Square root both sides. Okay, how do you square root a negative number and get a real number? You don't. So what values of x could I plug in to give me a 0 here? How could I get a -4 when I'm squaring this x value? You don't. So the domain is x is equal to all real numbers. This double R thing means the set of all real numbers. So everything that's in the real number plane. Okay? Next, x squared plus 27. What does this look like? Yep, it looks like a parabola. Tell me about the domain of parabolas. Yes, x can equal all real numbers. We don't have any breaks in our graph. Okay? P of x, square root. What does a square root function look like? So it's just sketching this. I remember that this is my h value plus k, which is plus 0. So my h is actually opposite, so I'm going to go negative 1, 2, 3 and graph my point. A square root just goes like, we're just going to sketch it in, looks like that. So where does this graph start from? Well, it starts from negative 3, x equals negative 3, and then it goes onward from there. Okay? So how would I figure this out without kind of knowing what the graph looks like, or if it's really complicated underneath the square root? What can't you take the square root of? I can't take the square root of a negative number. Nope. So what I'm going to do is set up the inside. I'm going to take this part, this calculation, x plus 3. What does it have to be greater than? It has to be greater than or equal to 0. Anything bigger is okay. So we're going to be like x has to be greater than or equal to negative 3. That's my domain. True? True story. Okay, we're going to pause this here, and you're going to have another video on function notation and even and odd functions.